launch a web server. What are the web servers you have used? HTTP? Anything else?
No, that's it.
Okay. No engineers?
That wasn't structured in.
There are more than seven, more than a few. Right?
HTTPS. Expensive.
So since this Thursday is the exam, rather than distributed, oh, did I do it? Looks like I left. So no clicker. So rather than distributed systems, we're gonna talk about the edge computing, a lighter topic, but it ties well with the serverless computing, the trend, the evolution from virtual machine, container, serverless, and then different aspect of the computing, right? So we're gonna talk about that today.
Is this going to be part?
Exam. We are going to have a quiz on these two today in class. Open note.
This is going to be included in the mid?
Included in the exam. Yeah.
Okay.
So I don't have a clicker. Looks like I left my clicker, the signal receiver in the other classroom. Okay. So what's the topic that we have talked about last time? Serverless computing.
Serverless functions.
And Linux, right?
Linux.
Yeah. So we have done the Linux quiz, right? I hope that was fine. By the way, Linux experience can be a maker or not for your jobs. In fact, for my any research assistant, Linux proficiency is that would be very important. So many people have done web development, Python development, but the Linux experience will tell me whether he or she can do the relevant research work. Okay, so that's important. The slides or the quizzes are really basic ones. Those are included in the exam as well. So at least at that level, I want you to know. But real experience, there are a lot more for you to learn, and that can be only done through the real experiment, real practices. So recall that there are the list of the links that I posted, right? Linux cheat sheet and the other the intro materials. Please go through them as you need, right? Questions, comments? So this Thursday we're gonna have on the first exam. It's going to be, that it's the no talking, no cheating, right? No open note, but still you use your laptop, Responder's Lockdown browser. I hope you have all tried Responder's Lockdown browser, right? So you have an experience. Don't forget to bring your phone, because not even Responder's Lockdown browser, for you to get in, you need a two-factor authentication, right? So, yeah. But after that, you will have to leave your phone on the floor and things like that. Okay, so exam types, questions will be somewhat similar to the quizzes. Some can go a little deeper. You know that there are a couple of questions that you come up with on your own. You have seen it on the trial test, right? The same question will appear on the exam. The same questions will appear on the exam 2, exam 3 as well. So any topic at the graduate level, you are expected to, to be in charge of your own learning, and not just, strictly following the items and memorizing them. You are expected to really self-motivated and go deeper on the topic. But on those questions, you are not supposed to make a question on storage virtualization or network virtualizations. That's out of the scope. I constantly see students doing that. I also may have. Would you like to see a test question?
Definitely.
So you have seen the quizzes, right? I might I might have it available. Okay, so yeah, but that means that questions will be a lot different. I saw some students actually working with the previous exam questions, and that's really unfair for other students, right? I try I want you to think about coming up with your own question. Always that's a good study habit, no matter what the subject is. But still, I'll give you some because, basically it's similar to quiz. Maybe some of them may be not, right? So since you have some experiences already, nothing to be afraid of. Okay? Typically I say that the exam is your celebration time. It's a show off time. All of the knowledge you have, hard work you have done, you can show it off without speaking much. A lot of CS people are, introvert and nerds, and often hate some people who keeps just talking on you, right? This is the opportunity that you can just show off about yourself. Well established way. Okay, so just try to enjoy such time. I hear always from the music performers, how do you get over all those nervousness and so on? Their advice or their comments is that, well, that's a celebration time, right? I know it's easy to say than doing it. Anyway, at least I don't want you to feel afraid or scared, right? So no, that's not my purpose. My purpose is not squeeze you and try to show off my knowledge. That's not the case. I really want you to be proud of your study and knowledge. Okay. So last topic today, any questions, Father, about the exam? So as you have seen the two questions, it can be some descriptive, but I don't want you to write a long novel. Okay? So some students really does write thoughtful, the lengthy comments. But in our class, I want you to be really concise, get to the point. So either maybe just a phrase or words, or descriptive one. I mean, the example, define cloud computing in your own words, things like that. So in the descriptive question, if I have more than those, I really want you to get to the point directly, not writing a long novel. Some students feel that if you write a lot, typing, or in a paper-based one, writing multiple pages, can I get a more paper and write longer one? Typically, they're talking about completely something different, right? Yeah. Think about the other side. If you're the grader, if you're the instructor, how you're gonna grade it. I can immediately find out the keywords in there, right? And whether this is relevant or not. Any other questions on the exam or anything? Okay, so today we're gonna talk about some computing again. What are some computing you have heard of so far in this class? Cloud computing. What's that? Grid computing. Distributed computing. Serverless computing. Anything else? Utility computing, right? So we talked about a lot of computing, and today we are going to talk about edge computing. Any comments? What comes to your mind when you hear about edge computing? You might actually say that edge computing is not cloud computing, right? Cloud computing is where computing is done in remote, big, a few data centers, right? Edge computing is where the computing is done at the edge. So what is the edge? Edge is also again a term coming from networking. Cloud shape. It's a symbol for a network, right? So edge is it's a networking term. When we talk about the networking architecture, internet, ISP, there are tier 1 backbone network providers like T-Mobile, AT&T. You might think that T-Mobile, AT&T, they are really cell phone, the network provider that provides the connectivity from user equipment, user device to maybe cell tower. Well, they do a lot wireline backbone network service. In fact, that's they are the real the internet service provider, and they also provide the different ways of providing internet network access. So there are tier 1 big ISPs that has a big connectivities, but one company cannot make all the connectivity to all of the people around the world. So some company, AT&T, T-Mobile, Verizon, previously, there has been other companies too. So they have their big customer base. Their customers are either tier 2 ISPs, smaller regional ISPs, or end user customer as well. So there are tier 1 ISP, tier 2 ISP, and then tier 3 or end users. So the one that is close, edge is also term, we call it edge network. And also when we talk about the internet, the network architecture within an enterprise, say Cisco.net or any, including UMKC. If you look at the UMKC network, I think I have shown you a picture before. There is a core network, and then aggregation layer, and then the access network. So access network, in other words, we also call it edge. So edge computing, edge is where it's a way. So the opposite word of edge is what? Core or centralized place. Edge is it's at the trim, outside, closer to the boundary. That's what it means. So computing is done at not at the central big data center, but done at the periphery, the boundary of somewhere which is closer to the user. That's what it means. I don't have a clicker, so I'm using this. So this is the idea. Pushing applications data computing. So computing is done to the edge of the internet. So if it's not an edge, at the middle there's a core. Edge is really closer. Is where it's close to the users, end devices, mobile devices, and sensors. Right? In other semesters, I talked about, I think, the CDN first, and then edge computing. This semester, I changed the order. Okay, so CDN is an example of edge computing if you actually think about it. What does CDN stand for? Content delivery networks. You have a hint already, right? So it's a network of servers designed for content delivery. Content like what? Netflix, videos, or Chiefs game broadcasting, those contents, right? Content delivery So in order to deliver such content to a large number of users that are distributed around the world, there is a special network designed called CDN. Later we are going to talk about CDN at the storage part. Akamai is the main example. In fact, Akamai, like many other things we see in cloud computing, it's a company that was started by a professor and student, starting from their research work. So as you will see later, maybe I'm telling you, you may have a less surprise if I tell too much. So they actually started this idea really early. What do you think, since I brought it up? How early? Cloud computing, late 2000, that's when it was starting to emerge to the general public, right? The Akamai CDN, they started this idea earlier or later? Earlier. How earlier? Way before, so it's the late 90s. In the 90s, mid 90s, late 90s, before internet was that popular to a lot of people, they had this idea and kind of network. Today's wonderful performance that you have for Netflix, all those things, thanks to this idea. We'll talk about it more later, so you have a better appreciation on that later. But edge computing, the idea again is pushing computing to the edge. So computing is done at the edge. Edge meaning closer to the user, closer to the things that are happening, closer to where data is generated or where data is used immediately. So again, CDN, that's an idea. So how is it to do with the cloud computing? Well, think about the applications, like IoT applications. The sensors, will be on the ground, where people are living, where things are happening, traffic signal, or any temperature, even the IoT recycle. If that recycle bin is full, then it needs to be emptied. That kind of detection is necessary at the trash can. So really at the edge. But it has to be, data needs to be collected, to sense data, and somehow processed, and maybe cloud can do big thinking based on a lot of gathered data. So IoT sensor on a trash can is just one data, but it might have thousands, hundreds, thousands, or a lot of the data coming together, and it can be all viewed together and visualized and analyzed together. That does require bigger computation power, right? So this is application structure. Sensor and some computation based on these sensors aggregated. And then these can be all put together, aggregated together for a global or bigger scale computing. So this is the architecture we can think of. So for these really important and popular applications. In this example, the sensors or where things are happening are very dispersed geographically, not just one city, not just one traffic load. So the lot of devices, a lot of data, it needs to be scalable. So that's computing characteristic. This is architecture. I hope you already immediately appreciate it, and the characteristic would be it's very distributed, not just a few data centers, and therefore it's very scalable. Many places can get connected to, and these applications, especially IoT applications, not only distributed but also autonomous. You don't want people to manually configure and stop operations right? You want all these things to be done automatically. So for edge computing applications, we want things to be autonomous and distributed. And that's actually before I said it, so this is a really, does it make sense, edge computing, right? It makes sense for IoT applications like this, right? So if we didn't have an edge computing, then whatever sensor, it has to be connected to the internet through the cloud directly, data center directly. We are having this edge infrastructure, right, that sits between the centralized, the big, larger scale data center and the sensors. So this architecture, I hope it makes sense, right? Then what kind of benefit can it bring? So in terms of, say, performance, right? So the typical performance metrics are what? What's that? CapEx and OpEx is in terms of, cost, right? The let's see. By having an infrastructure, how it can improve the CapEx and OpEx. I mean, that will be certainly the case. You went to a different direction than I anticipated. That's really the, maybe, working with the cloud directly can be more expensive because you might have to do a lot of, you might have to pay the number of clicks, number of connections to a centralized server. And the edge can actually reduce because it can aggregate the data, right? So CapEx, the CapEx and OpEx, it's something from business perspective. How about performance perspective? What's the, I mean, not in terms of the finances. What? Bandwidth. So performance metrics are bandwidth and bandwidth, a lot of different types of bandwidths, right? And then what's the other one? When you when you run some application, wow, this works well. What does that mean? A lot of data, you can get it quickly. That means high bandwidth. And what else?
Response time.
Response time, delay, right? In other words, latency.
Latency.
So bandwidth and latency. What about the latency? If you have an edge computing, do you think the latency will be reduced?
Yeah.
Yeah, obviously. Why? If whatever sensor has to interact with the central cloud server that can be in different part of the country, big country, or a different continent, right? The latency will be huge. So edge computing, this edge the gateway or edge infrastructure is closer to where things are happening, can be like in the co-located in the cell tower. So that means low latency, right? Communication between sensor to a cell tower is a lot smaller, or some local city server is a lot smaller compared to from here to the East Coast, West Coast, or even satellite. This geographic distance makes a big difference in the latency. If you think about the latency, transmission delay, queuing delay, processing delay, and then propagation delay. Propagation delay is to do with the physical distance. 2/3 of the speed of light. That's the signal propagation speed. So and then multiplied with the distance. That will be propagation delay, and that's not something you can do about it, no matter how the stronger, better, bandwidth device you might have. So latency is a big issue, and by having an edge, you're gonna have a low latency. I have actually put both together. Next one. So low latency, the quick response. that's really, really important for a lot of, say, delay-sensitive applications. And then another thing is a contexture. So all of the data goes to the cloud to centralize the server. Then it has so many data from different places. It kind of we may not recognize the special pattern of the local context. So by having this edge server, a lot of benefits. First of all, like low latency. Another one is the contexture. Well, this is an area that temperatures is somewhat, and you can aggregate the data, and you can also do special command based on, say, temperature or traffic pattern, traffic density on that region. So the decisions can be a lot more relevant to the area. Low latency allows real-time interactions, right? And the contexture actually is related to the different region, different type of the sensors. You can make a separate, different relevant decisions. So again, in the central cloud, when it has every data, it might have a blurred understanding of whatever things may happening. Heterogeneous activity, real-time application, those things can be possible through action. So previously I was, glorifying the cloud computing. It's a cloud computing class. Now I'm saying that hey, having everything done on in a remote data center, it's not a really great way, especially for these applications. So it's better to do the computation away from the cloud and do it locally. That's what I'm saying. So you might say, oh, that sounds like the opposite of cloud computing, but as this architecture shows, well, you can do this edge or local computation, but eventually they can be connected to a cloud server. So with this architecture, we do take advantage of great things that edge computing can offer, and also great things that cloud computing can offer. Bigger storage, bigger computation. Right? Data center is a big and powerful, can store a lot of things. Edge is so many closer to where things are happening. It has smaller in the computation capability and also the storage capacity too. So this idea is good. What are the real drivers? So we have listed those things. It seems to be good, but is it really good? Killer, the performance that it brings? Yes, especially for latency-related applications. The RTT round-trip time will be huge if you can keep communicating with a remote data server. I mentioned about CDN as an example of edge computing. Before we had this edge computing word, it's relatively a lot more. Edge computing word came out a lot later, cloud computing, right? So it's a cloud computing, and then, hey, not cloud, but edge. That's what it means. So it came later, but CDN, in fact, we had it since late 90s, means that we had this idea. Now we see that, come to think of it, that great thing we had before, that's an example of edge computing. That's what we need to know. So the CDN really allows low latency applications. Without CDN, you cannot have Netflix. Without CDN, you cannot have ESPN streaming watch or cheap stadium. A lot of applications we are enjoying now is really thanks to the idea of edge computing. Bandwidth also can be optimized. You don't have to send everything to the cloud server, edge server, or edge computing node can aggregate, summarize data when it sends to a cloud, and also data coming from a cloud, rather than cloud server sending all the same redundant data to all of the sensors, IoT sensors. We can just send it to a edge, one stream to an edge server, and then edge server can communicate, duplicate that one to a lot of sensors, right? So we can reduce or eliminate unnecessary redundant traffic, optimizing the communication channel. So latency is a big one, bandwidth is a big one, and before actually I showed this, anything else you can think of, then I told you before, if you are not sure or don't understand anything in the meeting, you can still say something, and that is, what about security, right? And this is the same thing here too. Privacy and security, is it a plus, do you think, or not? You already saw this, right? So next, the edge computing, it's amazing. We talked about the various characteristics, but really amazing thing is that latency and bandwidth optimization. And also there's another one that is privacy and security. Privacy and security, do you think edge computing provides better privacy and security? And answer is yes, right? Because I put it in drivers. Why does it provide the better security or privacy? What do you think? How about Lavi? What do you think? Yeah. Okay. So, do you think edge computing will provide better security and privacy? I said yes, it does. Okay. Yes, it does. Well, actually, you may say no. If you don't think so, why? I mean, I can think of some argument that cloud may provide a better security. Anyone wants to add this?
Isolation.
Isolation?
Because
You mean why the edge computing
is
can
secure.
provide the better security?
Yeah.
Okay.
Because the system's isolated, so it's not connected to the world, which makes it less prone to attack from outside.
Exactly. Yeah. Right. So you don't send everything to the cloud server. Therefore, you are making data less vulnerable to the open channel. Right? Yes. That's the thing. And you can also aggregate data or just summarize it. Rather than all the temperature, you can just send the average temperature only to the cloud server. But you don't show all the data points that are read like every 5 minutes and so on. Right? You might only send the water usage per month to the cloud server. You don't have to say what are each times. You don't have to reveal what are the times of your taking shower time or the lawn watering time, things like that. You're not revealing. It's more private. That's a better privacy, right? But Lavi could have argued that cloud server could provide a better security in terms of, what do you think, anyone? Some security services does require more computation, and maybe cloud server will be better off having those the security service software available and also computation power available, and edge server may not have all those services up and running. So in that sense, cloud server might provide a better security. So the data staying local, not really sending to the other one. Another one you can actually think of, before I say that, you can also keep thinking what are the great things that drivers, that edge computing makes great, then and people get motivated to use this edge computing model rather than just sensor and cloud connectivity directly. So another thing is the connectivity. So what does it mean? What does it mean?
Available
More available? Yeah. Why?
because it is at the edge of the network and it is more reachable for the user.
Right. That's exactly the case. So think about the cornfield. You know, the say humidity sensor, and you may not have the connectivity from all of the cornfield place to the internet, right? So you might have actually sensors communicating at the corner of the field aggregator, the edge aggregator needs to be connected to the internet. Right? So sensor may only needs to speak, you know, Zigbee to another sort, or you know, Bluetooth, some other device, and that the other device can have an internet connectivity. Right? So the connectivity, if you have a long road or a long path, internet or road, you know, traffic issue can always happen, and can happen in a greater scale, and just the more issues with the connectivity, or you may not have any connectivity at all in some cases. So once you have a continuous connectivity, you can always continuously connecting the data, right? And the context related one, it can really depend on the end user and whatever the local context. We can also make computing like that. Like a sentiment of the restaurant. In our case, it's mostly everybody is connected to internet, so it may not be the perfect example. But I actually want you to think about such examples. Even political sentiment, you can keep finding out the people's sentiments depending based on the local area, and do the processing regardless of where the other area might be. So that's a general view of edge computing. I hope you are kind of, at least I try to buy you that edge computing is a great thing to do. I hope you are bought by the idea. Then the next question you might ask is that who provides this edge computing infrastructure or edge computing, you know, the power? What do you think? It can be, I mean, the where, I don't have a latent thing. So edge device, edge server has to be geographically distributed, or at least to the place where things are happening, right? So who can provide the edge server? Labi, can you have an edge server for, you can actually use your laptop for and make it as an edge server, okay, to the group of sensors. You go to, like a student and any activities, right? Like in previous case, we were trying to do crowd analysis, and there are IoT wearable tags worn by students in some student festival, right? International Student Festival. So a lot of people are gathered, and they have IoT devices, and research student bring a laptop and try to collect the movement data. So that's an edge server, and that the laptop is an edge server. So edge server can be whatever application developers, right? you have a
So,
comment.
so you said like you're using like laptop and like the server, right? So if one of the laptop get hacked or like down, it's gonna be affect all of the connection between all the devices together, right? I'm talking about the security. So yeah, so if you have like a bunch of laptop connecting together at the server, like at computing. So if
Right.
one of us, like one of these,
Right.
hacked or like down,
Yeah.
it's gonna affect like all of them. Right?
Only the devices that your laptop is connected to. Right. So, but it's the case, right? So in that sense, security might be better with the cloud. Somebody might say that because your laptop, you may not have all the patches up to date, and right. So it can be more vulnerable. But still, in other aspect that I mentioned, the data, not all data needs to be connected to the internet and a server. So it has a less shorter road to travel, less vulnerability. So you can argue. I can say some argument. You feel free to come up with your own, right, and it can make sense. So right, that's the case. And we are talking about what's the context that we are talking about is that who can um, provide the edge computing power? Any even so your question may be edge server. How powerful it has to be? Can my laptop be an edge server? Answer is yes, right? But if we are talking about bigger one, maybe someone with infrastructure might be better. So telco, Sprint, no, the T-Mobile, AT&T, they have cell towers everywhere, right? It's very closer to the people. So they can actually provide the edge computing. So this is a big opportunity for telcos providing this new computing service on their existing infrastructure. They can have a micro data center. If you actually look at the Dell, HP, IBM, they actually sell micro data center. That's another opportunity for those vendors, as well as it's opportunity for telcos. So there has been related word, mobile edge computing, mobile access edge, things like that. Right? So there has been a lot of the kind of trend, movement, activity around this edge computing. The Lavi's laptop, I keep picking on you today. Right? It's a mobile and it's an edge server, right? So that's the that can provide that can enable interesting applications. Another words that are related to, I think I mentioned before, fog. Fog is like cloud in terms of just physical shape, right? Cloud computing, the word is not really because of the physical cloud, but as a symbol from the networking to abstract the connectivity, right? But if we consider cloud as a physical cloud in the sky, that is something remote, that is something big. Fog, on the other hand, is something similar, the whitish water, the made of water, right? So fog is a smaller form of cloud that are closer to the ground. So in that sense, there is a word fog computing introduced, and there has been consortium like that too. Open fog consortium. Actually, let me correct this. Business model is still not clear. I would actually rephrase it until last semester. I would say not clear. Maybe it's getting clearer. I would say that, right? So the business model, a lot of technology really is technology driven by industry making a big momentum, societal change. It's all due to business model, right? The cloud computing, exactly the case. It can enable, lots of business activity that was not, they couldn't have done before. So business model with the edge computing is getting clearer. The question is, who pays for the service? Who is the consumer? Who is the content provider? So those are the questions to ask, and it is being answered. What do you think? Can anyone think of a business model or some business where this can be a service, this can be the consumer, this can be the provider? What do you think? In fact, anything about IoT or edge, there are just so many applications we could think of. Yes.
I mean, we saw the Apple Vision Pro lately, right?
Yes.
So it has some local computing about
Yeah.
augmented reality, and so
Exactly.
product-based things can be a good business model.
Right. Yeah. So that's then you can think of right. Yeah. So around that application, remote surgery, right, or even gaming, right, with the
Virtual.
AR/VR device, and it does require lots of computation. So AR/VR device, it can be either done on the headgear, which is becomes heavy, expensive, or it can be tethered to the computer, right? So in that case, yeah. So the service is, say it's a remote surgery, consumer, doctors, right, and patients as well. The provider can be content provider, can be maybe hospitals, right? Yeah, so that's an example. Google does a lot of things first, but these days they are not really, they are they missed the opportunity to get the big recognition, like the AI field happening. Google has been doing the farming, so there are the farm or anything that are happening on the physical world can be made smarter through the digital technologies and farm status sensing. Then the consumer can be farmers. Content provider can be really Google and other the farming related businesses. So it is becoming a lot more clearer now. Now that can be a really big one in the near future. By the way, telco could provide this. The telco has the one who has an infrastructure, the most infrastructure, and they should actually take advantage of this. As a side comment, the telco companies, how do the internet telco companies, how they basically, telco companies are internet service providers, right? Before telco companies were the internet service providers, they were just providing internet service, telephone services. Telephone service, you have to have a wire, connected. If you want to call from East Coast, West Coast, there should be wires. And the companies who had a railroad became a telephone company, right? Companies who had a cable TV connectivity, because it's a TV company, they have to have the wires. They become an ISPs. So they have to have such an infrastructure. Telco now, ISPs, they could have provided a lot of value over there and become really big. But telco has been not just my point. I think there are a lot of people also starting to see that they have been not so smart, right? So instead of telco, the AT&T, T-Mobile, Verizon, they have all the infrastructure. They could have made a lot of money. Their stocks, or they are not really doing a lot of things besides what they have been doing all the time. Google, the Amazon, Microsoft, those are the ones who are creating something new big technologies and making a lot of money and make a big impact in the society, right? So telco has been actually, I think it's even now infamous to miss the opportunities, good opportunities. I think they are also missing the opportunities even in edge computing, right? Because as you will see, I'm talking about this in a cloud computing class. So soon I'm going to talk about all these cloud computing companies, they provide the edge services. Seemingly it's the opposite of cloud, but cloud companies does almost everything now. Cloud provider, so this is slide I was going to talk about. The cloud provider can provide edge computing services like Azure IoT Edge, Amazon Cloud Front, Greengrass, Snowball. All those are cloud provider offered edge services. They do not only software and infrastructure platform, they also make and sell hardware as well. They also try to provide big content to CDN services. Early CDN services like Akamai, what they have done is they have a lot of servers around the world, around the country and around the world, where they cannot just put a server in the middle of cornfield every 1 kilometer or so, right? They put the server co-located at the top point of presence of ISP. Right, so that's how they started. Google or the Amazon, they have a data center started as a one and then a few. There are several data centers in the US and more in the different countries as well. Still, it's not like thousands. It's not like hundreds, right? But still, they're making a lot of connectivity. They can say now they provide the CDN services. So Azure IoT Edge, as I said, the AWS Cloud Front. You say the word front, edge. It's closer to the user. Front in front of the user, not just back end or where things are happening in the data centers. So they are providing all these services, Lambda and Edge. The next question you might ask, what are the good things from a provider perspective, good thing to offer? Maybe cloud, serverless, lightweight computing services. That's what they have been already, you thought about it? If you have, I'm sure they already thought about it and offer those such services. So cloud, edge, and sensors and controller IoTs or devices, right? AWS Snowball is a hardware. They offer edge computing device. So they provide the data center in a box, push the cloud computing capability to the edge in a smaller scale. So what do you think? It will have network connectivity. Everything internet network is their minimum, and then the other computing memory storage services bundled together, and it should also have an intelligent logic to connect to a central server, the adaptive routing. So who are players in this field for edge computing? When you hear the word edge computing and I try to motivate it, it makes all good sense. Then who provides it? It can be telco, it can be cloud provider, and then also who can make money besides these services. The edge server needs to be the shaped they put together in a way that it can interact with the more valuable the service systems, like all the attractive things that are available on AWS. So you can think of the traditional hardware companies like Dell, EMC, HP. they can do that. And also Cisco, traditional router vendors, hardware vendors, they can also do that. And also Amazon, Google, cloud providers can also make hardware. Google makes all the servers. They make phone as well, right? Phones, servers, and data center router, backplane, the the racks. They make all the hardware as well. So they do the software companies who used to be a software companies. Now they do hardware as well. So these are the players. So if I ask you who are the players, not just a traditional server company, not just the routers, but the cloud provider also are playing in this field. Not just hardware also, but all the services. If you have a new service, what do you think? Don't you think the Amazon Edge server would be a good thing to use? Because it must have or the well connectivity or seamless the interoperation with the other services available in AWS. Suppose you are already familiar with a lot of AWS services, then you want to have a new application using IoT connected to an edge server and eventually public cloud. Then maybe such the edge server coming from those public cloud provider, it make your work easy, right? So that's what's happening. So I'm using actually slide from a talk who gave the nice positioning presentation about the edge computing, and the person actually tried to sell this is a great thing, previously for IoT applications, but also government as well. So think about the military, humanitarian, public safety, public service, the healthcare, traffic, disaster relief, law enforcement operation. These are the applications where edge computing might be very useful. We actually have written proposals and papers, a lot of papers actually you can see how we can provide these the services when the internet connectivity is poor, or the computing resource is not abundant, right? So when there is an earthquake, tsunami in some certain area, infrastructure cell tower will collapse and internet connectivity will be a problem. And you can bring some edge server, collect the data, eventually made it connected to the internet, right? So that's the thing you can do. So smart city, smart everything, the application, you can think of a lot of things. And everyday usages too. The phone can be an edge server. It can do a lot of things. And the edge server, these are the typical things you might need, like even door, security building, door, you want authorized people can only access it, speech recognition, facial recognitions, and the other AI applications. These require computing, and it can be done without connecting all the way to the cloud server, right? So these are all good applications where edge computing can be very useful. So this is the good summary and also the gist of the idea. Cloud, it's so cool, but if we have combined with edge, then we can do all these cool things. Pre-processing, prefetching of the data, pulling from different remote places closer to where things are happening, and also from the application or on Earth, we can filter data if it's the privacy vulnerable, or also if it's not necessary at all. So the filtering unnecessary data between the end device and cloud. Prefetching, pre-processing, these are all real keys to make things perform well, right? How can you should actually amaze like all the internet activity services that are happening now. How can it be that fast? How can it work that well, right? You might just consider it of course, you might be just what's the word, spoiled by the performance, or just take it as for granted. But behind it, there are so many cool techniques happening, and many of them you can categorize as this is a prefetching, this is a pre-processing. Right? So that those can be done really well through edge device. Mentioned that reducing bandwidth, reducing latency, and also filtering unnecessary data, computing as well, so reducing the load. Prefetching, pre-processing, what it means is that processing it in advance, right? Or pulling data in advance, caching. So that's what it means. In agriculture application, you can also think about a lot of cases. The resource challenged environment, disaster, or rural area, or underdeveloped countries, or area, rural area of even this country as well. We can call it, in general, resource challenged environment. Not every device is, not every school, or not everything is well connected to the internet. Then we can still do something using edge computing. So what I want to also say that, well, so far we talked about the cloud computing isn't it all amazing, glorifying it, and now I'm making a case of the edge computing, which is almost the opposite of the philosophy of cloud computing. And what will be the next? You might want to think about it. And this is the technology evolution, technology evolution, or technology, the changes over the time, and we see it goes in cycle. So we had a big mainframe computer, mini computer. Mini computer was big, right? So that wasn't really centralized computing, and then the mini computing also, I would say, yeah, mini computer is over there. Mini computing is this. So we had a centralized paradigm, and then PC decentralized paradigm, cloud computing centralized paradigm, and now we have edge bulk computing decentralized paradigm, right? Blockchain decentralized paradigm. And then later we are going to talk about the software-defined networking. It is a centralized paradigm. Before software-defined networking, we had autonomous distributed routing, traditional routing that's used in the current internet now. That's what is used by ISPs. But SDN is often used by cloud data centers. It's a centralized platform. So it goes back and forth. So my point is that don't think that, decentralization is an amazing thing to go. That's the way to go. Or centralization, cloud computing is the way to go. Don't be stereotyped in such a way. The things go in cycle, and each paradigm can make a better sense in different environment and time, right? Isn't it interesting that technology goes in cycle? Always the question you should ask whenever I glorify something or making a case for a new the concept, you always have to think, then is it really the case? What are the the downsides? What's coming on ahead? What are the things that needs to be improved? So those questions you have to have always for any technologies. For edge computing, the hardware it's still being formed. Edge computing, it can be Lavi Spectrum, or it can be, so that's a general purpose computer, right? But it can be specialized for edge computing applications. These days, AI is a common applications, and hardware needs to be better equipped for such applications. Privacy security, we said it in general. Data is not exposed to others or to a lesser group, so it's maybe more private, maybe more secure. But is it really the case? Maybe security patch is not up to date, so it could be a problem too. So we really need to ensure those good things that we can think of, and then the resource allocation. So edge computing, by definition or default, resources are limited, scarce, compared to the cloud server. So then you matching right server to a right computation needs would be important. And that means also, if you have a big field, you have a few edge servers, which sensor will be connected to which server, the resource discovery is another issue. So these are the research topics. You can think of hardware companies, software companies, all of these application developers are all relevant, right? So these are, so resource discovery, right? Aggregating resource. These are, anyone, this is a Tupperware. Do you know, maybe international students may not know it, Tupper party? Have you heard of that? Tupperware is a plastic made of good material. And there has been, like, their business marketing, it's so-called pyramid, and they have a party, have a good, social event. At the end of the meeting, they say, it's basically selling plasticware to people. And it's not sold from a company with a big advertisement from Super Bowl advertisement. It's actually advertisement through a small group of people, right? Another one, this is a Joneses. This is a movie, not necessary. I think it's a rated R. But the idea is that the goods, marketing, selling, the way they sell is that the fake family go into, maybe I shouldn't spoil the spoiler. The fake family go into some rich, wealthy area and have all these products wearing and showing off. That way, they can make the people around to buy that product. So this is really going to the customer, closer to the customer in a small scale, and make them use it. It's the idea. It's somewhat similar in that sense. The further challenges there are. Let me stop here for today, and the quiz is available. I will add more time. Access code. Access code is what do you think? Tell me the access code. I will extend the time till maybe 11:30. So these quizzes are not to make you suffer, right? This is this helps you to feel more confident toward the exam. not share the code with the other people. I know. I still notice the number of students who have taken the quiz is greater than the number of students who have attended. I'm keeping the note of it. Once you are known, the student can be in trouble. So don't share the code with anyone else. I let you to take it twice. The latest one will be used. And once you are done, you can also see the answers, I think. So take twice and you can get all the things done.